All right, please do not move to example 7 and 8 until you're very good at 5 and 6, because if you're not good at 5 and 6, these are questions that build on one another. This is just going to get confusing. So if you have not completed 5 and 6 and practice 5 and 6, please stop this video, go back and do that. If you have and you're comfortable and you're pretty quick at getting the points and understanding what you're looking for in terms of the slope, you may continue. So again, I'm going to do one, you do one. So I did the perpendicular one last time, you do the parallel one. All right, so I think I'll stick to that same thing. So my question says, what is the equation of a line that passes through this point and is perpendicular? Again, by definition, remember, what does perpendicular mean? It means that it meets at 90 degrees and I'm flipping and changing the sign. For you, what does parallel mean? It means that the slopes are exactly the same. The y-intercepts must be different. All right, so now that we know our definitions, let's go ahead and do this. It says, follow the steps in Desmos A that you should have the slope of your new equation. Okay, so I don't even need to look at my steps for Desmos A because I've practiced this enough, but I'll do it again. Type in your equation into Desmos. So again, I'm doing example 8, you're doing example 7. So 3x plus 5y equals 40. All right, so to find the slope of this line, because if I click table, it won't do anything. So to find the slope, I'm going to come to the spanner. I'm going to hit minor grid line so I can see it better. I'm going to zoom in so it's going up by 1s, 2s, whatever you want. And I want it to go, in fact, I'm going to make it go by 1s. And I want to look for corners. Again, do not pick the easy one, which is the y-intercept or the x-intercept, because you'll be given questions that don't fall on 8. They fall on 8.2, and you can't choose that. So I'm looking for corners, so I'm just boom, 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 boom. And again, if you need any help with this, you want to let me know. When I think I found one, I'm going to hover. I found 5, 5. So I'm going to put it in a table. So 5, 5. And again, that's what it says. Type the equation into Desmos, zoom out, see the line, find 2 points and put it in a table. Make sure the dot's on the line for you to have pulled it correctly. So boom, it appears on that line. I see 5, 5. I can click it. I know I'm good. All right, let me find another one. Here's another one, I think. All right, and 10, 2. So I'm going to go 10, 2. And it's appeared on the line. I can click it. It stays. I know that I'm good. Click the flag and look at M for the slope. So now I know my slope is negative 0.6. So I'm going to copy that. Oh, and I forgot this because it's been a while. If you click this, it'll copy it for you. And then I can just delete all my extra things here, make it a fraction. So my slope for this line, which we know we call M, is equal to negative 3 over 5. Okay, so if I want the one that's perpendicular to that, what do I have to do? I have to switch these around and change the sign, right? So I switch these around, so it's going to be 5 on top, 3 on the bottom, and the negative becomes a positive. So my new slope is 5 over 3. What is my new y-intercept? So I got to keep going. So for you, what's your new slope? So now you should have found the slope for your new equation. So the slope for my new equation is 5 over 3. Input another table. So I need another table. I'm going to delete this because I don't need that again. So I'm going to put in another table. And in this table, I'm really looking for my y-intercept. So I have my slope. I just need to find my y-intercept. So input another table with a point that the new line must pass through. So my point must pass through 6, 5. All right, 6 and then 5. All right, now here's the problem. I need another point, right? If I had another point, I'd have my graph already. So I have to find that point. So here's this point on the graph right here. I know it's going to be a line that does this, and it has to pass 90 degrees, and these slopes must multiply to negative 1. If yours is parallel, you know yours has to do this, right, because it can never touch it. So you kind of have an idea of what you're looking for. All right, now here's the kicker. We haven't done this since the beginning of the semester, but for some reason, it won't tell me anything until I type in y2. So because we've been doing the flag thing, that's not there. I do have to type it in like a regular equation. So let me just remind you. We have y equals mx plus b. So that's what we're going to use. So we're typing in y equals mx plus b. But remember, it always gives you an error because it doesn't like two things. Number one, what values do you want it to use? So I want it to use in my table, and please look at the numbers for yours. Mine is x2, y2. So everywhere I see y, I need to put a 2. Everywhere I see x, I need to put a 2. What I'm telling the calculator is, hey, use the numbers in this table. Well, here's a problem. There's still an error. That's because also the calculator doesn't like an equal sign. It wants a squiggly line, which remember is shift and then right underneath escape. But if you can't find it there, you can click ABC and it was on the bottom here. Yes, it was. All right, so boom. Go ahead and tell the calculator the slope you want it to be. Now remember, it's giving you a slope for m, but you want to tell it what m is. You want the slope of this line that you're creating to be whatever you got so far. So I want my slope to be 5 over 3. So what I'm going to do is I'm going to come to m, and I'm going to say, hey, I know my new line slope is 5 over 3. So you can see that it immediately, now that you've told it what the slope is, it's going to tell you using these 2 points and this slope, your y-intercept has to be -5. So I'm going to write my slope here. You write yours and yours. So if I was to write the equation, I know it's y equals m, which is 5 over 3, x plus b, which is -5. But I definitely want to type that into the calculator to check. So I'm going to say y equals 5 divided by 3, x minus 5, and yes, it matches perfectly. Now the last thing I want to check is sometimes this does not look like it's a 90-degree angle until I hit home, or maybe I zoom in a little bit more. It just depends on what the question is. So do these look like this could be a 90-degree angle? If you put your hand in an L, does it fall on this one and this one? Yes, it does. All right, so this is good. This is my line, y equals 5 over 3x minus 5. Again, by definition, we know that my slope is perpendicular, which means that I multiply my new slope of 5 over 3 times my old slope, and my old slope was -3 over 5. I will get -1 because these slopes are reciprocals of one another, meaning it's been flipped and the sign has been changed. So don't forget to always check that. So if it's perpendicular, it has a reciprocal slope, and y-intercept could be the same or different, but the most important thing, it has a reciprocal slope. So for parallel, it has to have the same slope but a different y-intercept. Again, get very good at this question. Let's practice.